Hi, I'm Rachel Meyer, and this is my Concepts of Nuclear Weapons presentation. Nuclear bombs are weapons of mass destruction. They involve forces that hold the nucleus of an atom together. At the center of every atom is a nucleus. Splitting a nucleus apart is called fission. Splitting the nucleus releases large amounts of energy. Nuclear weapons use that energy to create an explosion, a shock wave, and nuclear radiation fallout. Nucleus. The nucleus contains most of an atom's mass because that's where both protons and neutrons reside. Strong forces hold protons and neutrons together. The proton-to-nucleus ratio determines the stability of an atom. There are both repulsion and attraction forces between proton and proton and proton and neutron and neutron and neutron. If the repulsion force outweighs the attraction, the nucleus disintegrates and can emit radiation. Isotopes with atomic numbers higher than 83 are radioactive and are called radioisotopes and are unstable. Radioisotopes used in nuclear bombs. Fission, uranium-235 and plutonium-239 are isotopes used in nuclear bombs. Uranium-235 has 92 protons and 143 neutrons in its nucleus. Plutonium-239 has 94 protons and 145 neutrons in its nucleus. Radioisotopes emit three kinds of ionizing radiation from their nucleus. Alpha particles, which are two protons and two neutrons, beta particles, which are high-speed electrons, and gamma particles, which are high electromagnetic energy photons. Nuclear fission is splitting a nucleus. Nuclear fission is the process of a single free neutron splitting a heavy nucleus into two lighter nuclei and one or more neutrons. A neutron must be slowed down to split a heavy nucleus. There is a small amount of mass loss from splitting the atom. The mass loss is called mass defect and is converted to energy called nuclear binding energy. A large amount of energy is released during the nuclear fission process. Nuclear binding energy. Nuclear binding energy is calculated by using Einstein's energy equation, E equals mc squared. E is the binding energy, m is the mass defect, and c is the speed of light. Nuclear binding energy is the energy required to split the nucleus into protons and neutrons. Nuclear bombs use that nuclear energy to create an explosion. Nuclear fission of uranium-235, the isotope. In nuclear fission, the heavy nucleus absorbs the neutron that hits it and quickly breaks into two lighter parts. More neutrons are produced than originally absorbed in the process, which makes possible for a nuclear chain reaction. Fission reaction is on my diagram. Nuclear chain reaction. To get enough energy to cause an explosion, a nuclear chain reaction of heavy nuclei must occur. A nuclear chain reaction is a self-sustaining sequence of nuclear fission reactions. The neutrons produced in the initial nuclear fission can bring about more nuclear fission in nearby uranium-235 nuclei, which produces even more neutrons. For a nuclear chain reaction to occur, enough uranium-235 must be present to absorb the neutrons, which means critical mass of uranium-235 is required. If a critical mass is present, many of the neutrons produced will be absorbed by other uranium-235 nuclei, and a chain reaction will occur. Critical mass is created inside the bomb by using explosives to force the fissionable materials together. Detonating explosive will force subcritical masses together to form the critical mass required for a nuclear fission chain reaction. The resulting fission explosion is devastating to the surroundings. Fallout is the radioactive fission particles that fall to the earth as a result of nuclear bomb exploding. Once the nuclear bomb explodes, a fireball that can reach millions of degrees Celsius is created from the energy of the explosion. A shock wave is produced that causes great injuries to humans and damages to building structures. A mushroom cloud forms when everything inside the fireball vaporizes and is carried upward. Radioactive fission material from the nuclear bomb mixes with the vaporized material in the mushroom cloud. Fallout results when the vaporized radioactive fission material in the mushroom cloud cools down, condenses to form solid particles, and falls back to the earth. Fallout can be carried long distances and contaminate surfaces miles away from the explosion, including food and water supplies. Nuclear explosions produce both immediate and delayed destructive effects on humans and the earth. Energy released from the nuclear bomb dropped on Japan was equal to 20,000 tons of TNT. Buildings were vaporized, people were vaporized and burned severely. 70,000 people were killed. 40% of the Hiroshima's population died, and 60% of Nagasaki's population died. Nuclear radiation released from the nuclear bombs caused thousands more people to die from radiation sickness in weeks, months, and years that followed. In 1945, Sadako Sasaki was 2 years old and lived 1 mile from where the nuclear bomb exploded. In 1954, Sadako was diagnosed with leukemia caused by radiation exposure from uranium-235 in the nuclear bomb. According to Japanese legend, folding 1,000 paper cranes grants the person one special wish. Sadako folded 1,000 paper cranes before she died in 1955. In 1958, Hiroshima Peace Memorial Park placed a statue of Sadako lifting a large paper crane over her head. Here's more of the statues. Each year, people drape Sadako statues with paper cranes with healing wish for peace on Earth. Conclusion. Nuclear bombs are weapons of mass destruction. Critical mass of radioactive isotopes called radioisotopes are created inside the bomb so an uncontrollable nuclear fission chain reaction can occur. Inside the nuclear bomb, nuclear fission is triggered, which splits the isotope's heavy nucleus into lighter nuclei and produces intense energy and more neutrons. The nuclear fission chain reaction releases nuclear energy and creates an explosion whereby radioactive particles are drawn up into a mushroom cloud. The mushroom cloud is filled with radioactive fission particles that produces a nuclear fallout that expose people to radiation. This concludes my presentation of nuclear weapons. Thank you for watching.